A pool table made by Brunswick Billiards comes in three sizes of playing area. The first one is 55 inches by 100 inches. Second one is 46 inches by 89 inches. And the third one, 36 inches by 78 inches. And the question is, at least for part A, determine the perimeter of each table. So the key word here is perimeter, and we can't really do the problem without knowing what that word means. And the word perimeter, let's put it over here, is total distance around. Total distance around the shape. Now, it doesn't matter if it's a square, triangle, pentagon, rectangle. The definition is the same for any polygon. You just add up all the sides. Look at the total distance around. And as with any word problem, I'm a very visual learner, as I've mentioned to my students many times. So if there's the possibility of drawing a sketch or a picture to represent the problem, that's always where I start. Okay, so we have 3 pool tables. So let's look at pool table number 1. We call this number 1, and the dimensions are 55 by 100. That means 2 of the sides are 55. And 2 of the sides are 100. Then we have pool table number 2. I'm going to just draw them the same size, even though they're different sizes. The second one is 46 by 89. So 2 sides of 46, 2 sides of 89. And this is pool table number 2. And for table number 3, 36 by 78. Okay, so now it's, by drawing a simple sketch like this, one of the benefits is that it limits or greatly reduces the chances of you making a careless mistake. So for example, a mistake I've seen in the past made a number of times by students is looking at only 2 of the sides as the perimeter. So the table number 1, maybe a student would say 55 plus 100 is 155. So that's the perimeter. But when you have a sketch like this, it's pretty obvious that if you know the definition is the total distance around, you visually see there's 2 55s and 2 100s. Okay, so to answer the question, the perimeter of each table, well, the perimeter would be add up all the sides, 55 plus 55 plus 100 plus 100. And if you pop that into a calculator, you will get a total of 310 inches. Now, I've done all the calculations ahead of time, so I don't have to pull up the digital calculator and spend time in the video doing that, but these are things you would do on the calculator. Okay, table 2. Let's go back to blue. Table 2, add up all the sides. 46 plus 46 plus 89 plus 89, and that is 270 inches. And if you don't believe me, of course you could pause the video and double check my calculations by plugging them into a calculator. And table number 3, 36 plus 36 plus 78 plus 78. And if we added those 4 numbers up, we would get 228 inches. Notice I'm including the units in my answer because anytime you have a word problem where the numbers have meaning, in this case the numbers represent inches, you always want to include the appropriate units. Okay, so for part B, by how much does the area of the largest table exceed the area of the smallest table? Okay, well, we're not looking at perimeter here. We're looking at area. So the largest, when I say the largest table, that means the largest area, and the smallest table would be the smallest area. So what we need is the area of each one of these tables, and we need to know what we mean by area. And in the context of a rectangle, the area is length times width. the length and the width. So with the perimeter, we're using the length twice and the width twice. With the area, we're only using it once. Okay, so let's get a little bit more room here. So table number 1 was 55 by 100, so the area would be 55 times 100 for a total of 5,500. And since we're talking about area, the units would be square inches. So we could just say inches with a little exponent of 2, that's inches squared for short, or you could write out the word square inches. Okay, so that's not an answer to the problem, but we need that to figure out the answer. Okay, table number 2, the area would be 46 times 89. And 46 times 89 is 4,094. Again, I did this previously on a calculator. And table number 3 would be the 36 times the 78. And if we multiply those two numbers, we get 2,808. And that's, again, square inches. Now, the length times width, width times length, the order of these numbers doesn't matter as long as we have one of each. Okay, so we have, it looks like the largest would be table number 1, and the smallest would be table number 2. So we're looking for how much bigger is the larger table than the smaller table. So to answer that question, we're going to have to subtract. We're looking at the difference. So we're looking at the difference between the two. And anytime you're looking at, how much bigger is this than this, or how much more is this than this, and anytime you're looking for the difference, that always means you subtract. And you'll see this a number of times as I go through the 20 problems on this practice exam. All right, so to answer the question, we have to take 5,500 square inches and subtract from that 2,808 square inches, and the difference would be 2,692 square inches, and I'll say square inches larger. So table number 1 is 2,692 square inches larger than table number 3. Okay, and that about does it for this problem.